Hi, I'm Prof. Melko, PhD chemist, university professor, and today we're going to talk about significant digits. We got digits right here, 1, 2, 3, 4, 5, and they're all significant, right? Sometimes these are called significant figures. So let's jump into the lecture and learn something about it. Measurements are listed to a certain decimal place, and the number of decimal places you list has something to do with significant figures, sometimes called significant digits, sig-digs, or sig-figs. So this is usually determined by uncertainty. So if you don't know what uncertainty is, go back and watch the previous video where we covered precision and uncertainty. All scientific measurements come with this uncertainty, and that determines this number of significant figures. We also talked about in the previous video how you might have different instruments. So if you're measuring out a nickel, you might have different types of balances. A really precise one might be a digital balance that weighs it out to the thousandth place. So a nickel might weigh 5.000 grams. Okay. If you have something more rudimentary, you might only be able to weigh it out to 5.0 grams. So the 10th place versus the thousandth place. These are different levels of uncertainty, and so we keep track of their digits accordingly. Right? These have 2, 3, and 4 significant figures. But the rules are a little tricky. Trailing zeros like this after a decimal point always count towards the number of significant figures. Right? Leading zeros before a decimal point never count. Right? They're there so that we can specify the size of the number. So down here at the bottom of the screen, if something is 0.5 centimeters long, we need the 0 there to make sure we know just how small it is, but it's not significant. Okay? Both 0.5 and 0.005 centimeters have the same number of significant figures, 1. Okay? Whereas the trailing zeros after the decimal point do count. 2 sig figs, 3 sig figs, and 4 sig figs in these measurements, respectively. Let's look at another example. Say you have a stopwatch, right? Maybe the first one is pretty rudimentary and only measures an integer number of seconds, 1 second, 2 seconds, etc. You upgrade a little bit and get a stopwatch that measures out to the 10th place. Then you get a little bit more money and maybe you buy one out to the 100th place. So you all measure some sprinter running a certain distance. A, B, and C measure 35 seconds, 35.1 seconds, and 35.08 seconds, respectively. Right, you can see the better the stopwatch, the more precision we can get, the least uncertainty. But the sig figs are different as well. 35 seconds has 2 sig figs, 35.1, 3 sig figs, 35.08, 4 sig figs. So in examples like these, it's pretty straightforward to just count up the number of digits as all significant, right? But it gets a little trickier when you have leading zeros, trailing zeros, scientific notation, all things that we'll discuss over a series of videos. So let's break down these rules. Okay, if you encounter a number and you want to know the number of significant figures in it, rule number 1, count digits from left to right. Okay, always start at the left side of the number and move to the right. Okay. When you get to the first non-zero digit, that is the first significant digit. Okay, don't include placeholder zeros. Right, so 0.11, I don't count the 0. That does not count as a significant figure. I do count the 1, that is the first non-zero number I've gotten to, moving left to right. And I do count the second one. So there's 2 significant figures here. In much the same way as I move left to right, there's 2 significant figures in 0.011. Don't count the first 0, don't count the next 0. The first number I get to is a 1. After that, that is a significant figure, and everything after that will be significant as well. Moving left to right here, the first non-zero digit I get to is in the first place here. That's significant. That's significant. Okay, but this last 0 is not significant. Okay. So trailing zeros like this don't matter unless they're after a decimal place, right? So I can back up a little bit, right? Trailing zeros after a decimal place do count, but trailing decimals or trailing zeros without a decimal place do not count, right? I need to write the 0 so I know it's not 11, it's 110, okay? But it's just a placeholder, right? I don't know that. I don't have that level of precision, so it's not significant. Okay, so that's one little wrinkle, is that these trailing zeros, if there isn't a decimal place, are not counted as significant. Okay, rule number 2, sig figs only apply to measurements. right? So something you're taking out a ruler or a stopwatch and making a measurement, you're going to write down that measurement with units. You have to keep track of significant figures, okay? You don't keep track when you just count things, right? So here's 3 Kendrick Lamars, exactly 3 of them. 1, 2, 3. I've counted them all up. I don't have to worry about significant figures in that case. In much the same way, there's exactly 100 centimeters in 1 meter. It was defined this way. Okay, I don't have to worry about counting significant figures, and I'm going to use these types of relationships for unit conversions, and that's what we're moving towards. So let's stop briefly for a quiz. You can pause the video here and try to answer this. In a few seconds, I'm going to work through it myself. So let's determine the number of sig figs in these volumes. First, 0.450 milliliters. The first rule says move left to right, okay? And I'm going to keep moving until I get to the first non-zero digit. That's 4. That's significant. That's significant. Zeros, sometimes they're significant, sometimes they're not. Remember the rule. After a decimal place, these trailing zeros, meaning at the end, they are significant. So this would have 3 sig figs, or significant figures. Next, 5.00. Moving left to right, the first number I get to is a 5. That's significant. There's 2 trailing zeros, but they're after decimal places. So again, 3 significant figures. They all matter here. The last one, 10,000 milliliters. Moving left to right, the first number I get to is a 1. That's significant. All the rest are zeros, so I kind of have to check, is there a decimal at the end here that specifies these are certain? There is no decimal, so none of these are certain. They're all uncertain, and this would just be 1 significant figure. So that's 3 quick examples of significant figures. There's some rules involved. It can seem easy at first glance, but make sure you spend some time mastering these rules because you're going to use them a lot in science. So that's it for this video. In the next few videos, we'll learn about adding and subtracting measurements and what you do with significant figures. Similarly, we'll worry about multiplying, dividing. You keep track of significant figures slightly different in that context. As always, you can check me out on YouTube and subscribe, and also every week on Twitch at twitch.tv/profmelko. I have office hours where you can ask whatever chemistry questions you want. We also talk about the latest science news over there on Twitch as well. So come join the community, and I'll see you in the next video.